Hi my friends, today we model this part which is made of two parts. One is this one, the other this one, and the drawing is this. You see, this is part and this is another. They are mirrored, being identical except for the two holes. As you can see, here is a through hole and here is a threaded hole. As you already know from the previous tutorial, the source is also from Timoteo Carrera Soto, but the part is not this one, but this one. A couple of two symmetrical objects, number 4 and number 5. About this drawing, I want to tell you that these sloped faces are not well. They must be like these, vertical, because you see here the sphere from the end is visible since we have this arc, and you cannot create a part with this sloped faces, because the sphere will be contained in that sloped faces. I decided to make this vertical, as you will see. This part is taken from Timoteo Carrera Soto drawings, and you can download it by watching the tutorial number 182. We'll create the parts as a single volume, then we split that volume to obtain the two, and after this we'll apply the holes. As you can see, there are some dimensions here and some other in the other part, because we see the two parts from external or internal view. We start with this contour and we continue with this one in the first sketch. New standard millimeters IPT, XY plane. We draw a circle with diameter of 22, then an arc starting from somewhere here on the circle, ending somewhere. We draw a line, vertical line of 40 millimeters, then another arc from this end to the circle. The two arcs are equal but symmetrical. I draw a line from this midpoint to the left of 25. This dimension is in the drawing, and I place this line on this center. I move this point up and I apply symmetry of this with this about this axis. We don't have a dimension from this arc. We only have this dimension of 67. But the radius doesn't exist. You see? We have a dimension of 14 between these 2 points. 14. But not the radius. This is why I consider that we have to draw a line here, which is a construction line, to place tangent the arc at this end to the line. This one will be the same. Good. You see the centers of these 2 arcs. In the drawing there is no dimension for these 2 arcs. Okay, now I draw this combination of arcs with radius 5 here, and this is an arc with a radius of 75. I suppose I was wrong before in my sketch. No, I didn't. I draw a circle with radius of 75 and an arc from the circle to this point and tangent to the arc only, to the circle. The radius is 5 and this point is coincident with this point. I make this line, these 2 lines as construction. I mirror this arc about this axis and I trim the rest of the circle this is to be somewhere here, and we have a start for our sketch. Then we continue with this arc of radius 68. You see this distance of 46, and then the other arcs, I don't mention them, but this is 25. That line I made before, 25, this point. Good. Circle with a radius of 68, a line, a vertical line, this one, as a construction line. I trim the rest of this arc and I place dimension here 46. Then another arc starting from here like this, then a circle with radius 9, which is spherical, will be spherical, placed at 100 from the center point, and 52 on vertical, 52. This end of the arc comes to this circle, and they are tangent. I draw a line of 18, horizontal line of 18, and I continue here. These two are construction lines. This arc is radius 45, and there is a missing dimension, but I suppose not a dimension. Let's see. Oh, this line, which is not important. I can continue that line to have no missing dimensions. Now I draw a circle with radius 9 again, tangent to both, to this circle and to this line. I trim this and I draw a line from this end to this point. I mirror this last line. Mirror is here. This line above this axis. Done. And I create an arc from a random point to this end with a radius of 15. Trim. You know what is with this point. This is the mirror of this end point. 2 dimensions needed. Let me see what are that dimensions. Apply this angle and this dimension. Where is placed this point? That point is placed here. Oh, this is not finished here. Tangent must be these two, and other dimension I don't. You see, I lose the mirroring. This is why I apply symmetry between this point and this point, no matter how long they are, about this. Now I can eliminate this point, I don't need it, and we have a fully constrained sketch. Okay, we have a sketch with 2 or 3 combined entities. I draw a line here because I'll share this sketch. I draw a line which I want to be coincident with the center of this circle, and I split this arc and these 2 points. This and this must be construction. Why? Because this will be the sphere and this will be the extrusion. I must cut, split these 2 and make here a construction arc. The last thing to do is a circle of 8, because we extrude not radius 8 but diameter 8. Control Z, circle, center, diameter of 8. Okay. Now I extrude this contour and I take care of the dimension, which is 33 plus 33, because I create the volume containing both halves. Extrude this and this symmetrical on 33 multiplied by 2. Okay, very interesting. Now I share the sketch. Share. You must be careful. This is here and its double is up, always up. You will know why up, because we use this for all the features which goes down. I create a new extrusion of this area with cut on a distance of all this minus twice of 8. Okay. I don't hide the sketch, but I want to show you where is that twice 8. You see the thickness of these 2 is 8 to both. And when we want to know what is the distance between this face and this face, we must consider these 2. Good. Now I extrude this face symmetrical on a distance of 6 multiplied by 2. Okay. Another feature is obtained with the revolve. This area by using this axis. Okay. Now I can hide the shared sketch, or here is the same because they are twins. Now we apply this fillet radius 4.5, fillet radius 2, and here again 4.5. This is 4.5. Also here, here, and here. Then 2 is the value of this contour. Okay. Now I make visible the shared sketch and I apply a new plane based on this and containing this point, the axis of the sphere. I hide the shared sketch and I create a new sketch here. I project lines from behind, this one, F7, you see them here. I continue projecting this line, and these segments. Finish sketch, extrude that contour to this face. Okay. Now we have the sphere very clear present there as the drawing. My drawing has this and Timotheus this arc. Now I continue with this cylinder, this, which has dimensions. For instance, radius 40 is a new dimension here. 24 at a distance of 5 from this 36 measured from here. Okay. XY plane sketch. I make visible the shared sketch because I need some entities from here. I project this arc. I also project this construction line. Then I make it not visible. A rectangle. This bottom line is a center line. It must be aligned with the center point, tangent this end line to this arc. The distance from this face to this line is 36 plus 5. The diameter is 24. I draw an arc from here to the line with a radius of 40. This must be tangent to the left line, and we have a fully constrained sketch. Finish, revolve. I select only this, not all. The axis is known. Okay. Now I want to create the hole inside as a revolution, diameter of 16, and this end is placed at 36 plus 67. XY plane, sketch, F7, rectangle with a corner right here in the center point. This bottom line is a center line. This length is 36 plus 67, and the diameter is 16, my friends. Finish sketch, revolve, select profiles. This is the profile, the axis is known, and cut. Okay, now the two holes. You see 37 is the distance between them, and 79 the distance from the center point. This is a countersink hole with a diameter of 9 and 90 degrees, the hole of 5 millimeters, and the other is a threaded hole on a depth of 45 metric 5. Let's apply these positions. F7, I draw a line, a vertical line of 37. I place its midpoint on the same horizontal with the center point. Then I place 2 points at the ends of the line to have to show to Inventor where I want to place holes. The first is countersink and not threaded. This diameter is 9. This diameter is 5, okay, and the depth is half of this, which means 6. We have 6 as a dimension on the drawing. 6. Both holes are created. Okay. Then I select again the hole tool, but not threaded, not countersink, but threaded. Threaded with metric 5. Okay, full depth. This is the end. This is 4.5, and the place is this face with this center for the first, plus the same data for the other one. This is the face. The other is placed here, centered, and the depth, everything is okay. The last thing to do is to split this in two pieces. Split, select the tool is the plane XY, and we select both entities. Then we move one of them, for instance this one, on the direction of Z, of say 40 millimeters, the other direction. Okay. Now we can save this two. You see there is a gap here. I should place this not tangent but internal. We can edit this, because this is the first revolution, and I edit the sketch. F7. I don't place tangent here. I eliminate this and I place on the same vertical, or no, I place this line. You see, I can move it coincident with this endpoint. Finish sketch. Now you see it is another situation. I don't verify the volume, but I apply the material stainless steel. Now you can make a movie with this by selecting this orbit option, going to this horizontal, keeping pressed the shift button, and then apply a small movement. You see that you have all around at your will. Escape, and it comes back. Then you can apply shaded instead of viewing the edges. That's all for today. Thanks for watching. Bye bye.